Question 14, you've got a straight line there, and so you know the equation of a straight line equals y equals mx plus c. All you've got to do is figure out what y, mx and c are. So on the y-axis, we've got log to the base 10 of p. The gradient, you're told, is 1 over 300. On the x-axis, it's actually t, and the intercept, you can see, is 2. So that's actually the first 2 marks just there. To find out the actual model for this, there's 2 ways of doing it. I think it's easiest just to continue working with this. And how would you get rid of the log to 10? Well, you'd do p is 10 to the power of all of this. And we can break that up and say that this is 10 to the power of 2 times by 10 to the power of 1 over 300t. Of course, 10 to the power of 2 is 100, and 10 to the power of 1 over 30, we'll have to work that out, works out to be 1.0077 to the power of t. And so here's our formula there. What does this A represent? Well, A represents, often we put here, we say it's going to be the initial population. So this one here is initial population. What you do is you think, if t was 0 here, this to the power of 0 gives 1, and so it is the initial population at t is 0. And this one here, it's the growth rate. It's the annual growth of the population. I mean, you could go further and even say that this is, that's not even 1%, is it? It's 0.7% per year growth, or about 1% each year. For part D, we're then asked to find out when t is equal to 100. That's enormous. So just put the 100 in here. So we're going to be 100 times by 1.0077 to the power of 100. I'll do that in the calculator. 100 times by 1.077. And it means that our population is now going to be 215. And part 2, find out the number of years it takes to get to 150. So we'll do 150 equals this. If you wanted to do that one there, you could actually do a shift solve for that one there, but we won't. We'll do it properly. We're going to do 150 divided by 100, which of course we know is 1.5, and then we're going to do log to the base 1.00, sorry, that should be an x there, 1.0077 of 1.5, and it says that n here will be 52.86 years to the nearest year. So the nearest year, I suppose, would be about 53 years. But these models are notoriously bad. Why with the population? So 100 years, lot changes in 100 years. So we could sort of migration, disease, and then even just small changes. I mean, we had to go to quite a number of decimal places here. So small changes in B make big changes in 100 years. So lots of reasons why the model predicts unlimited growth, but maybe the resources might run out. Maybe there's a restricted size, loads of different things to build.